On the left, a normal thermal profile, hot gases rise evenly is shown. On the right, the cold top problem, as you can see, all the heat stay at the bottom and the top is colored cold blue. So this is low optic temperature case, which is simply the top gas temperature falling below 100 120 degrees centigrade. That glowing uh, uh, glowing thermometer shows a dangerous reading of 95 degrees centigrade. Why does that matter? Low optic temperature is an early warning signal of an energy deficit of the furnace top, and in severe cases it can leads to 80 degree, a sign of cold hearth. So remember, a cold top is never just a number, it's a red flag for the major trouble ahead. So coming to the causes of the uh, low optic temperature is also very essential to know. And now let's see what causes the top to be cold. So this magnetic troubleshooter diagram break it down. So first, excessive blast moisture, wet air consumes, uh, wet air consumes enormous heat as water vaporizes. Second, high oxygen enrichment. So every 1% increase in oxygen can drop top temperature by around 14 to 15 degrees centigrade. And third is the cold and wet raw material. If your body enters cold, it absorbs heat before any reduction happens. Other causes include low blast temperature, overly aggressive cooling, and simply too high a thermal load, extracting too much heat in the upper shaft. So the key takeaway is the low top temperature is rarely one thing. It's a puzzle. Solve each piece and you stabilize the furnace. So coming to the our consequences of low optic temperatures. So let's talk about the domino effect. This slide shows what happens when you ignore a cold top. You will not listen to the furnace. So at the top of our cascade, a furnace with a snow capped top. First consequences, filter clogging. That is moisture condense, dust stick together and back filters block. Next, gas line problem. That same moisture create acidic condensate that crack pipes. Then equipment damage, valves, bells, top gear break under corrosive attack. Finally, production loss. In extreme cases, the heart can actually freeze solid and recovery takes a day or the weeks. And remember, the safety risk. Top gas at 80 degrees centigrade is a direct path to a cold, frozen, chilled heart, whatever we say, is a heart failure. So ignoring low top temperature doesn't just cost efficiency, it's risk your entire operation. Now coming to the countermeasures, so what we should do. So when the top temperature goes cold, you need to act fast. So think of this slide as your emergency control panel. So first button, increase fuel rate, add coke or auxiliary fuel, that's the instant energy. Second, decrease the blood moisture, cutting humidity removes a huge energy sink. And third, the increased blast temperature if possible. So more hot blasts directly elevate the thermal profile. And fourth, to improve gas distribution, stop cold gas from channeling up to the center. These are firefighting measures. They stabilizes the furnace in minutes to hours. They would not solve root causes, but they will buy you time to plan the real fix. So remember, fast, decisive action prevent a full furnace freeze. So coming to our these firefighting about the recovery. So this is the slide which is basically focused on the substantial action, and this firefighting is not enough. This slide shows long-term solution. So look at these three metallic pillars. The pillar one, optimize the burden. So use high reducibility center, control burden distribution. Pillar two is about the smart sensor, with the real-time monitoring and predictive control. And pillar 3 is about the advanced hot blast stove for the stable high temperature air. And here is a real example. ArcelorMittal Tobaro implemented a methodology to detect and correct temperature loop variation, and the result, improved stability, faster recovery. The lesson is clear. True operational excellence comes from systematic improvement, not just quick fixes. So predict, prevent, and optimize. That's how you keep the top hot. So coming to the proactive future. So finally, let's look ahead. These holographic furnace represents the future. Digital twin and AI real-time thermal monitoring that predicts problem before they happen. Carbon composite agglomerates, charging them lowers the thermal reserve zone temperature, creating a more stable profile. Maritime hydrogenated hydrocarbons or do also helps in raising the object temperatures, and underpinning all of these a zero fault maintenance culture. This message is simple. We do not have to wait for a cold top emergency. With the right tool and the mindset, we can move from reactive firefighting to proactive prevention. That's how we keep blast furnace safe, stable, and profitable for years to come.